right, back to our favorite topic, unit tests. Let's get an idea of where we're starting from here. Coverage run -m, unit test discover, coverage report -m, and that gives us a list of how we're doing here. Looks like we got screen at 71%. That's because we made changes to that screen class we haven't written new tests for yet. Game 29%, Word 31%. There's some work to be done. I want to have to keep typing those commands every time, so I'm going to make a change here. I'm going to go up to my root directory and I'm going to create a little bash script to do that for me. And go ahead and move that coverage RC file. There we go. Okay. So let's start with the changes we made to the screen class. I believe we added the get, goodbye, and put methods. So let's write some tests for those. So we want to mock the input, right? We don't want the unit test to actually try to get input from the user. And input falls under built-ins. So we'll specify what the user's saying. The user's saying foo. And then we'll make sure that that's what our class gets. So this is another example of how I like to write unit test to fail first to make sure my test is valid. Oops. Test should fail. It did. It really should say foo. Test should now pass. I know my test is good. And it's not doing much here. We're just saying, let's pretend the user types in the word foo. Is my screen class actually going to get that back? Yes, it will. It'd be hard to mess this up. All right, let's write our put method test. This time we're going to mock the print from Hangman. Scratch that. Let's go ahead and mock it as the built-ins. Print something. And let's see if the print was actually called with that. And again, let's write it to fail first. Now it should have a new line first. Oh, this should fail anyway. Mock print called with. Let's see if the test fails. It should, yes, because it should have been foo, exclamation point. Now the test should pass. And finally, the goodbye method. Now the goodbye method falls in that category of, is this really even necessary to test? Goodbye method's not doing anything. It's just a pretty way of putting in a bunch of new lines and saying goodbye. So, you could have a philosophical conversation here about whether or not you even need to write this. This is a good argument for 100% on unit tests isn't necessarily a mandatory thing, isn't even necessarily worthwhile. However, I would counter in this particular situation with, it's going to take us 5 minutes to write that unit test, and then we'll have 100%. So if it were going to take 3 days and be useless, then I'd say, of course, like there's no point in that. But if it's going to take me 5 minutes and then I don't have to worry about explaining why my unit test is only 90%, I say just write the unit test. So let's just do something like we'll capture all the output from the goodbye method and make sure the word goodbye is in there somewhere. Actually, I don't need this. Basically, we're just creating a comma separated field of all of the calls to mock print. So we're creating a single string. And we're going to start by making the test fail. Test failed because goodbye is an output, as it should be. And this should be sufficient for our unit tests for screen. And we should be at 100% now. And screen 100%. So let's move on to Word, which doesn't exist yet. A lot going on here. You always want to name your unit test with this test underscore so that unit test discover can find them. Instead of dictionary, we're going to want word. We're going to test word. Don't know that we're going to need a setup. Yeah, let's go ahead and create a word that we can use for all the tests. We're going to create something a little unusual with, we're going to mix case to make sure that our word class handles that okay. Because remember, we decided to make our game class agnostic to the capitalization. We decided to, shouldn't matter what we're passing into Word in terms of capitalization, that we were going to let the word class handle that behind the scenes. So we got to make sure the word class handles that behind the scenes. Okay, so let's test the alive property. Each test that returns true and false. So right off the bat, this word should be alive. We haven't made any guesses to it. As a refresher, the setup essentially gets run before each test. So each test gets its own fresh copy of this instance variable, this word. It's just, rather than each test starting off with, something like this, you can put it in a setup and this automatically gets called first. So because we haven't made any guesses, then it's alive. So what we need to do here is make a bunch of guesses to make it turn out false, or just set the underlying value to be false, or just set the underlying guesses beyond the limit. I think that should be enough. We got a correct guess in here to make sure that gets true correctly. So this should be, head torso, leg, leg, arm, arm should be sufficient to make it not alive. I'll go ahead and test these, make sure we're on the right track. 2 for 2. Okay, well, how about that incorrects property? So we'll go ahead and guess some both correct and incorrect letters. So P should be correct. And B should be incorrect. And C should be incorrect. And then let's make sure. Incorrects should only have B and C in it. Three for 3. What's next? Masked. We could do something similar there. So to begin with, it should look like this. Everything should be an underscore. Let's make some guesses. Let's guess Z and an incorrect letter. And how about P? Now let's see if it looks like it should. We think it should. All right, what's next over there? Solved. Again, we should test both returns true and false. If you notice, these are all pretty short. This is why you refactor your code into object-oriented style. This is why having long methods and long functions is a bad thing, and why having short methods and short functions is a good thing, because it makes writing the unit tests much easier. Okay, let's go ahead and solve it. I, Z, oops, A, it should be solved. Let's start by actually, yeah, we can test both. Actually, we can test both we can test both true and false in the same method here. We don't need 2 methods because right off the bat it should be false. No, it should be true. Next method here, next property is unmasked. Well, that should be easy. if you wanted to make sure that we were correctly capitalizing it here, you could also do something like probably overkill. But had we written these unit tests before we tried running it, right here is where we would have caught it. Okay, and the guess method. Okay, we need to test several things. We need to test guessing a correct letter, an incorrect letter, a duplicate letter, right? They guess this a letter they've already guessed before, and some kind of invalid input. Incorrect letter. Invalid letter. I'll say invalid input, because it might not even be a letter. And test a duplicate letter. So, correct letter. Now, some of this has already been tested. And if we were to run the, run the coverage report, you would see that, a lot of the guess method has already been tested. But we're going to go ahead and write these explicit tests anyway, just because it's more thorough. So this is a good example of why you shouldn't always necessarily rely on the coverage percentage. You should go ahead and write the unit tests as you think they should be, so you're fully testing everything, and then use the unit coverage results to kind of fill in the gaps. Just make sure that it handles the lowercase there. And uppercase. What do we care about? We care that the unmasked should look like this from that guess. And we should also say that the incorrects are empty. Let's test that one out. Good. If you're nervous about it, let's stick an A in there, make sure the test fails. Excellent. Okay, what happens on an incorrect letter? It gets added to the incorrects. Start by saying incorrect should be empty. Guess a couple incorrect letters. Guess a correct letter. Let's make one lowercase. Make that lowercase. So A should not show up in the incorrects. Should just be capital B and capital C. Again, let's write this one to fail and say, well, this should be a lowercase b, and see what happens. Good, because it should be capital. All the letters should be capital by the time word class is done with it. And what happens when they do an invalid input? I believe it throws a guess error, right? All right, so let's make up some bad guesses. Multiple letters, numbers, symbols, all these are bad guesses. Actually, let's do a single symbol and a single number. All of those should throw an error. And to check to see if something raises an error, you say self with self assert raises. In this case, it should be a guess error, which means we'll have to import that. one more to go. Duplicate letter, which also raises a guess error. Let's guess a correct letter. And an incorrect letter. Okay, let's check our code coverage. I think we're good. I think we've tested our edge cases pretty well here. I think these are some pretty good unit tests. See if we missed anything. Nope. Word. 100%. So the only thing left is the game class. Okay, this one's going to be tricky. The game class doesn't really have discrete units in the same way as the rest of our classes. This is long for a method. It's just calling other things. So the way I'm going to handle this, and we could debate whether this is the best way to handle it or not the best way to handle it, and that'd be fine. But because this really isn't, we're not multiplying two numbers together here. We're not taking a single input and doing something with that single input. We're looping. I'm going to write this to be more like, it's almost going to be more like an integrated test. I'm going to create simulated games and throw them through the game class and see that it handles it correctly. See that it prints the number of gallows, the gallows correctly. It has the right number, of clears. It clears every time there was a guess, that kind of stuff. So stay with me on this one. Okay, let's get started by, I don't know if I'm ready to set up yet. Let's create some simulated games here. We're going to create a series. We're going to say 3 simulated games. Let's do a perfect game. Let's do some misses. And let's do an invalid input one. And for each one of these games, we're going to specify the guesses that the user gave. And we're going to include the number of the gallows, like the number of which gallows frame should be displayed per guess. So a perfect game would look something like, the guesses would be P, I, Z, V, and A. Now, here's an example of, do you check your edge cases here? Should I be putting in capital letters? Should I be doing those kinds of things? I mean, we're already doing all that in the word unit tests. So there's no right answer. This is going to have to be a team kind of decision. This will have to be, what's your definition of done? Actually, I don't want to guess Z twice because this would be a perfect game. And if I guess Z twice, that would raise an error, and that wouldn't be a perfect game. I'm not testing that in the simulated game. I've got an invalid input down here. Down here, we'll both put in, non-letters, and we'll put in the same letter twice and see what happens. But for guesses, this was a perfect game. So if you think about it, the gallows should always be the 0th frame, and we should see it 5 times. We should see the initial one, after our guess of P, after our guess of I, after our guess of Z, and after our guess of A. So 4 guesses should show us 5 frames, because we got to include that initial frame, and they should all be 0, meaning they should all be an empty gallows. And that should be what our perfect game looks like. So let's throw some misses in there and see that our gallows are correct. So what do we say? EF. Or the word's gonna be pizza again. So this is a winning hand, but there are some misses in there. So same deal. It's gonna be 0 when we first start, first frame. We're gonna guess an E, so we should see a head. Then we're gonna guess F, so we should see a torso. Then we're gonna guess P, so it's still just head and torso. I, still head and torso. Z, still just head and torso. K should give us, I think arms are next. And then A is victory. We have 1 here, so the last frame should also be 3. And then finally, let's throw some incorrects in there. And a loser. They're going to lose this one. So, 8, cat. What? No, I wanted F again. How many are we going to need to lose? Let's see. This will be the head. Because we should not get penalized for these. These should just tell us, hey, these are incorrect. This should be the first time I've seen for this one, right? So this should just be a head here. Torso, arm, leg, and loss. So remember the initial 0, 8, cat, question mark, F, B, C, D, E, G at the end. All right, so we've created our simulated games, and we're going to need a mock dictionary object. We don't want a real word. We want the dictionary to return the word pizza every time. So we create a pretend dictionary that looks like the real one. And that this get is simply going to return pizza. Okay. So we're going to create a game here, and we're going to use that mock dictionary that we just set up. And we're going to use a slightly different mock. This is mock patch object. I'm saying instead of the real dictionary object, return a mock dictionary object. So now each unit test should have a game object that was instantiated and it created and has its word that it got from the dictionary will be pizza every time, so we can properly run our unit tests. So let's test our start method. We hit start, game, and quit. So all we're doing with the start should be making sure that it calls game and quit, which is kind of lame, but what else does it do? So we can mock individual methods in an object, which is what we're going to do. We don't actually want it to call game or quit. We just want to say that it was called. So now when we call start on our game object, it will call these mocked objects instead, which are referenced here. And here's something I don't know if I mentioned in the other unit test video. The order of arguments that you pass into the unit test goes in order from the last to the first that something was mocked. So in this case, the first thing that's being mocked is the game method, and the second thing being mocked is the quit method. So since this was last, quit comes first. You can mock things all the way out here at the class level. And these would come even later because these will get mocked first and then these in order. So it would go, so let's say right here I mocked, some kind of foo up here, then your mock foo would go last here because it was done first. So that's very important. The order of the arguments to your unit tests is a reverse order that things were mocked. Last in, first out. Let's make sure that these work first. Good. So I think if we want to write it properly in unit test, we should use the self assert true. I will say I honestly don't know what the difference is. Okay. Now we could iterate through all of the simulated games in one method rather than do them separately. And that would certainly eliminate some redundant code. And normally I'm in favor of that kind of thing. But since these are unit tests, I want to know which one of these fails. Unit test really doesn't provide very good information when a unit test fails. It can be very difficult to track down exactly where or why it failed. So it's sometimes better to be more explicit, keep things separate, one per test, rather than loop. Because be careful when you're looping. If item number 37 out of 52 is going to be the one on your list that's going to fail, that's going to be really difficult to isolate. So rather than loop through these or iterate through these all in one function, I'm going to have three separate. I'm going to have a perfect, some misses, and invalid input method unit test for each one. So we're going to test game. Perfect. So I'm sad to say that you will see some redundant code in here, which normally gives me the heebie-jeebies, but it's necessary for our purposes. Side effect. Well, I guess I haven't mocked the get yet, huh? Right. So I mentioned earlier that you can mock things at the class level. Well, we're going to do that. I don't want to have to specify all these mocks every time. So I'm going to mock them at the class level. All these screen methods. Because I don't really want anything to go to and from the screen. I want to specify all the input and I want to watch all the output. I don't want to actually use that class for anything. So I'm going to mock all of it. Remember I said that these are all going to get patched for every method. And I put this in the wrong place. Sorry. So we need to account for that in our argument list. So if we were going to include all of these here, this order would be quit, game, and then working your way up. Get, put, gallows, clear. I'm not going to need those for this method. So I'm just going to put splat args in there. But I am going to need them for the game. Perfect. So what's the order? Mock get, mock put, mock gallows, and mock clear. Last to first. I don't have game and quit in here because I'm not mocking them. See, these are mocked at just this method, right? Just this unit test has game and quit mocked. These inherited the mock from the class level. Hopefully that's not too confusing. So a side effect is a way to return multiple, right, specify multiple return values. If I don't want to get the same thing every time, but rather I want to get multiple things each time it gets called, the mock call, I use side effect. In this case, my guesses are going to come from the guesses in my perfect dictionary, my simulation. I'm just going to specify the simulation variable here rather than type simulated guesses, simulated games, perfect guesses. This gets cumbersome. This is essentially just pointing at this to make it easier to write here and later. So now we can run the game, and we've simulated all the user input, right? The user is going to guess P-I-Z-Z-A. P-I-Z-A. We've also said the word's going to be pizza, so it should be a perfect game. So the clear method in the screen class should be called one more than the number of guesses because there's the initial clear. So if you guess 5 times, it clears after each one of your guesses to redraw the gallows. So that would be the number of guesses. And there's that initial clear when you first start the game. We can also check the gallows. Check to sure it's got these calls. I told you this was going to get tricky. This is our good friend list comprehension. So we're going to create a list of the mock call objects. So iterate through all of the gallows, create a mock call for that, put it into a list of calls, and then say gallows should have those calls. Okay, let's see if our test passes. No. Because I misspelled simulation. It happens. Oh, well, I misspelled it once. Oh, good. Okay, let's move on to some misses. Always make sure, this is an easy mistake to make, always make sure that when you're copying and pasting other methods, oops, I pasted it twice, that you change the name. If you have 2 unit tests with the exact same name, it's going to run the second one. So this one will never get run, but it doesn't throw an error or anything. So it's real easy to get a situation where you've got 2 tests covering both things and you're running your unit test coverage and it keeps saying you're missing this line and you're like, I've got the unit test right here. What's the problem? Well, that's the problem. So always be careful about that. Okay, it should be the same mocks. This time we're going to simulate with some misses. This should be the same. As you can see, this is why I gave the whole spiel earlier about I'm not going to iterate, because to be honest, the first time I wrote this, I did iterate it because it's just natural to, don't repeat yourself. I hate seeing code like this, but then it wasn't, the mocks weren't resetting. First of all, the mocks weren't resetting. And then second of all, I didn't have one of my guesses set up correctly and it was failing and I couldn't tell which one was failing. So even though it's duplicate code, this is the correct way to do it. And these should be the same. So we should have another test that passes. And then we need the invalid input. I think we called it invalid input. Let's go check. Yes, invalid input. Let's go ahead and make this one fail. Just to double check. Good. Unit test took a long time to run. Not sure what's up with that. So if you're following along at home, you may be noticing these unit tests are taking a long time to run. And if you recall, in our game class here, if the user makes an error, when we catch this guess error exception, we're sleeping for 2 seconds. We're giving the user a chance to see the error message we're spitting out before we're clearing the screen. Well, we're doing that in our unit test too. So that's kind of cool that the game simulation is working correctly, but it's bad and it's making our unit test take 8 seconds to run. So we want to mock that. Okay, let's see if that fixed it. Yes, there we go. Much better. I think there's one method left, the quit method. Do they say goodbye? We want our game to be polite. I don't care about any of the mocks, any of the class level mocks. But I will mock that goodbye because I don't really need to print anything. I just want to make sure that it's called. Our quit method might do other things later, but for now that's all it does. Okay. Moment of truth. Isn't that a beautiful thing? 100% all the way down. So now we've completed our initial Hangman program. There are some features I would like to add, and I think that would be an opportunity to show, how that unit test will come into play, how we'll, add on to the code. We'll do more things. It'll give you a good idea of why writing an object-oriented was so beneficial to us. It's going to make adding new functionality a lot easier. So we'll move on to that in the next video.